Hello, my name is Sydney Tuttle, and this is my Lab 1 for Physics 2 about charged tape. In Lab 1, I showed the idea that a charge is a property of matter and designed the experiment using everyday household objects. Specifically, I used charged pieces of Scotch tape, and after observing their interactions with both each other and charged objects, was able to determine their charge and excess electrons. You can see how the U-tape interacted with my hand to the right. Some fundamental principles shown in the lab are understanding charge interaction and being able to use Coulomb's law to calculate the electric fields and the forces acting on the tape, and using Newton's second law to determine the forces on the tape. By observing the interaction between U-tape on everyday objects, I was able to determine that U-tape had a negative charge. By showing that it was attracted to a hand, it was repelled from a negatively charged pin, and it was attracted to a neutral object, and it was repelled against the second U-tape, it clearly showed that it had an excess number of electrons, and it was negatively charged. Once the initial observations were complete, I was able to move on to the experiment, which was to determine the force exerted by one U-tape on another when they are measured a distance apart, and additionally to balance the gravitational electric forces to show that it's possible to float one U-tape above another U-tape. With this, I used tape with a width of 0.019 meters and a length of 0.17 meters. The mass of the tape was 0.00017 kilograms, and the distance between the two tapes was 0.02 meters. I also knew that the length of the atom was 1 times 10 to the negative 10 meters. The charge of an electron is 9 times 10 to the 9 Newton meter squared over Coulomb squared, and the gravitational constant is 9.81 meters per second squared, which means that the gravitational force, which is the gravitational constant, times the tape mass was 0.00167 newtons, and since the electric force is balanced with gravity, that the newtons would be 0.00167 newtons for that as well. Now that the initial observations have been made, the experiment completed, and the physics principles defined, we can calculate the charge of the tape and the ratio of the electrons to atoms. To do this, we need to make assumptions. 1, that each U-tape has the same charge, and 2, that the U-tape is treated as a point charge. To find the charge of tape B, we've already defined that the gravitational force is equal to the electric force, and the charge of a tape A equals the charge of tape B. Filling in the numbers we found in the previous slides, we know that the charge of tape B is now negative 8.62 times 10 to the negative 9 coulombs. Using this number, we can calculate the number of electrons on tape B, using the charge of tape B over the charge of the electron, finding that the number of electrons is 5.38 times 10 to the 10 electrons. In addition, the number of atoms of tape B is equal to 3.23 times 10 to the 17 atoms. Now, the ratio of electrons to atoms is found using the number of electrons over the number of atoms, which is 1.67 times 10 to the negative 7. This shows us that there is an excess number of electrons on tape B. Now we move on to the GlowScript computational model. I plugged in the constants and the observations made in the previous slides to define the variables needed for calculations. I also used the origin to determine the observation location for tape A and the distance found between the two in the experiment as the y portion as the vector for tape B. This moves us on to the calculations needed. First, I had to define the electric field using Coulomb's law. I used the charge particle charge and the observation location minus the charge particle position, and then I found the R magnitude and the R hat, and simply used the electric field formula. I returned this number. I also had to find the number of atoms, which I used the same formula as in the previous slides, and the gravitational force, which I used the same formula again. From here, I define an arrow to define the gravitational force and an arrow to show the electric force acting on the tape. Continuing with the formulas used before and the same assumptions, I was able to find the charge of the floating tape, the number of electrons, and the total atoms. And then the electric field for the bottom tape could be found. This brings us to our GlowScript results, where we can see the tape B represented by the red circle, tape A represented by the blue circle. The electric force of tape A on B is the cyan circle, the force of gravity is the green arrow, and the electric field of tape A is the orange arrow. Here we can see that the forces are equal and opposite, they act in a vertical manner, which makes sense, and that there is an excess number of electrons on the tape, which correlates with what we thought in the observations that the tape was negative. Following up with our results that the tapes have an excessive number of electrons and are negatively charged, what if the charges of electrons and protons were swapped? Well, this would mean that the tapes would still have the same charge, they would just be positive, and they would still repel each other, and still be attracted to neutral objects, but now they would be attracted to the negatively charged pin if the pin still was negatively charged. If all electrons and protons for all objects were swapped, then the pin would be positively charged, and so our observations would remain the same. It is important to handle the charged tape as little as possible because you want to avoid electrons being transferred and the result of the experiment being skewed. Thank you so much.